Alright, so last chapter, 7.1. Angles of polygons. So remember, polygons is just shape. General form of shape. Is it a triangle? Is it a square? Is it a rectangle? Is it a pentagon? Is it a hexagon? Is it like any of those things? Polygon is just the general word for that. So we're going to talk about interior angles of a polygon and exterior angles of a polygon. So, last chapter with triangles, we said, okay, all three angles add up to 180 degrees. So I think we all know that like a rectangle is going to have right angles. We've learned that before. So really this is like 90 degrees times 4 angles is 360 degrees. So if you notice, triangle 3 sides, rectangle 4 sides, and we have, this is 180 degrees, and then if you actually just add another 180, it equals 360 degrees. So when you add a side, you're going to add another 180 degrees to the total angles. So you can kind of visualize it by, like, if I have a rectangle, if I did that, well, I have two triangles. That's 180, that's 180. So if I did a pentagon, 5 sides, well, there's 1, 2, 3 triangles. So it would be, 180 times 3 is 540 degrees. So in all 5-sided figures, pentagons, it's going to be 540. And you can keep going and going and going. So there is a formula, and it's a theorem, but I'm not going to write down the name and numbers because I won't ever ask you for it, but Polygon Sum Theorem. So it's n minus 2 times 180, and n is the number of sides. So if you look at it, kind of these 3 examples, so we have like 4 sides is 360, 5 sides is 540, 3 sides is 180. Well, if you put the number of sides into this formula for triangle, 3. 3 minus 2 is 1. 1 times 180, 180. Rectangle, 4 sides. 4 minus 2 is 2. 2 times 180, 360. 5 sides. 5 minus 2 is 3. 3 times 180, 540. So on and so on and so on. Okay? So this formula, really important. Okay, so you'll have some problems that'll just say how many, find the sum of the angles of an interior of, and it'll always say convex. Okay, so this is only true for convex, which means it doesn't have any indentation. So if you look at, like, technically, that's a pentagon because it has 1, 2, 3, 4, 5 sides. They're not equal, so maybe I shouldn't have done like that part of it. But the interior angles will be different because that's not convex. Okay, can't have that indentation in there. So you will need to understand like the different like words for shapes. So if you don't remember them, you got to look them up. So 5 sides pentagon, 6 sides hexagon, 7 sides excuse me, heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon. Like, you got to look that up if you don't remember them. And then if it bigger than 12, it just starts to use numbers. 12 is a dodecagon. I don't know what 11 is, but like you'll have to do a 14gon. That just means it has 14 sides, or a 16gon, or a 20gon, or a 30gon. That's just the number of sides. They don't have names for them. Okay, and so then it might say how many sides if angles equal 900 degrees. Okay, so you're going to still use the formula. You just know that the answer is 900. So here's what you can do. So you could distribute, but that's going to make things a lot harder than it needs to be. You can just divide by 180. Don't do anything with the n minus 2. Use a calculator if you need to, but 900 divided by 180 is 5. And then you can just add 2. So it would have 7 sides. Okay, so you'll have a couple problems where it'll give you the total. Just divide by 180 and then do the add 2. It's really the same process for every problem, just instead of 900 it'll be something else. Okay, so any 4-sided figure is going to be, like I said, 360. Any 5 sides will be 540. Doesn't matter what they look like. Okay. All right. So then it is going to talk about this term, a regular polygon. So that means it's equilateral and equiangular. All the sides are congruent, all the angles are congruent. So the most popular version of that is a square. All the sides are congruent, all the angles are 90 degrees. Okay, so a square would be a regular polygon. Okay, so that word or that term is going to come up. Okay, all right, and we'll do an example of how we use that in just a second. So interior angles, n minus 2 times 180. Exterior angles, it's actually much easier. So if I did a pentagon and I kind of extended each of the sides out. So there's 1, 2, 3, 4, 5 exterior angles, just like there are 5 interior angles and there are 5 sides. So they're all going to always match like that. Okay, and so on the inside we do the whole n minus 2 times 180. So for this one we would have 540 degrees for the interior angles. Exterior angles, so if you think about, you're going to add 1 plus 2 plus 3 plus 4 plus 5. You're going to go from here to here to here to here to here to here, and I made a circle. Okay, and a circle has 360 degrees. So exterior angles of polygons equal 360 degrees no matter what the shape is. Triangle, square, rectangle, octagon, decagon, 40gon, the exterior angles add up to 360 degrees, no matter what. Okay, so that can be a huge help in some of the problems. Okay, so we could have, there's a couple different problems that you could do with exterior angles. So you'll have the same type of problems with interior as you do with exterior, but okay, well, there's 4 angles, but they're on the outside, so it equals 360. So I'm going to do 2x plus 89 plus 67 equals 360, because it's all the way around. So 3x, that's 140, 156. So that'll be 40204 divided by 3 is 68. Okay. So you'll have some problems like that with interior angles. Just remember the interior ones, to know the total, you'd have to do n minus 2 times 180. But exterior always 360. In this picture, because it's 4 sides and 4 angles, it's going to, the interior and the exterior are the same. But with the pentagon like right above that, angles 1, 2, 3, 4, 5 would add up to 360, where on the inside it's 540. Okay. All right. Then the last couple problems, it's going to ask you to find one interior and one exterior angle for a regular polygon. Okay, so regular, all sides are the same, all angles are the same. So when it asks you to just find, like it wants to know one of the interior angles equals 38 degrees or whatever it is, and one of the exterior angles equals whatever. That it just wants to, because all of them are the same, so it just wants to know what's one of them. And this technique that I'm going to show you and work with only works with regular polygons, and they'll only ask you this question for regular polygons. Now, the book does it one way, and I think it's just too long to do, so let's think about something. So we're going to do one interior and one exterior for an 18gon, a polygon that has 18 sides. I'm gonna, like, it has 18 sides. You can kind of, if you want to draw it, go for it. But at one of the sides will be on the bottom like that, and then one of the sides will come up like that to some level, and then it'll go all the way around. There'll be 18 of them. Well, here's an interior angle, and here's an exterior angle. Gotta keep right. And as I keep going up and around, there'll be an interior and an exterior and an interior and an exterior with every single one. So, you can do n minus 2, 18 minus 2 is 16 times 180. You're going to get this big, huge number. But I like to start with exterior. And I'm going to come back to this picture in a minute because the exterior equals 360 degrees. So really all I need to do is do 360 divided by 18 is 20. So one of the exterior angles is 20 degrees. Okay. Well, coming back to this picture, I'm going to make it a little bit bigger just to be able to write. If that's 20, well, that interior angle, that's a linear pair. It's going to combine for 180 degrees. So all I need to do is 180 minus 20 is 160 degrees, and that's the interior angle. I don't need to do this big process that you can see in the book if you want to look at it. It's just way simpler because exterior is always 360. Just divide it and then do minus 180 for the interior. Okay, so like you're not going to have to do this one, but one of them is like a 90gon. 360 divided by 90 is 4. So then the interior angle is 180 minus 4, or 176. Done. Versus doing 90 minus 2 is 88, and then 88 times 180. That's ridiculous. Okay, like so work a little bit smarter instead of harder, and we'll be good. Okay? Alright, so angle measures for polygons. Alright, so after today, the rest of the chapter is going to cover quadrilaterals, four-sided figures. So we did triangles. Now we're going to do quadrilaterals. Alright, so there's a lot of information in this chapter. I'm just letting you know. So the biggest two things for this chapter, or this section, is interior angles, n minus 2 times 180, exterior angles, all of them 360. Okay, those are the two key components for this section. All right, have a great day, guys. We'll see you tomorrow.